Hello everyone, welcome back to my additional mathematics channel. For today's lesson, I will share with you about the rate of changes. So actually, what is rate of change and how to use the chain rule to solve the rate of change problem. So let's have a look of this. If two variables y and x change with time t and are related by the equation y equal to function fx, then the rate of change dy dt and dx dt can be related by dy dt is equal to, okay, so I'm going to show you how to use the change rule. Alright, so dy dt is equal to dy times over dt. We just split out like this, okay? Alright, so after that we will fill in the blank. So the one that we need to fill in the blank should be dx. Okay, so that is how we start the change rule by writing dy dt equal to dy dx times dx dt. So please remember this. This is very important. This is so-called application of chain rule in solving rate of change. Alright. So for all the questions, we will use a chain rule. Okay. So now I'm going to explain to you how to solve the problem by using example 19. A curve has an equation y equal to x squared plus 4 over x. Find an expression for dy dx. So normally the question involving rate of change will start with the dy dx. So let's differentiate the y with respect to x. So it's actually 2x minus 4 over x squared. Okay, before that you have to write 4x negative 1. Okay, so after we find the dy dx, we will read the question. The x increases at a constant rate. So you have to convert these terms into dx dt. So let's read the question. The question says dx dt is 3 units per second. So we will just write dx dt is equal to 3 units per second. Now we are going to convert into symbol for rate of change of y. So rate means over time, comparing with the time. So dy over dt is equal to dy over something times something over dt, right? So we are going to substitute with the dx. Okay, fill in the blank for the dx. So in short, if you want to solve the rate of change, you must have the 6d, right? 6d. So you have to write dy dt equal to dy dx times dx dt. And how to find the value of dy dx? We just substitute the x equal to 1 and x equal to 2 into the dy dx, right? So because the dy dx is always depends on the value of x. So let's jot down the dy dx and let's substitute x equal to 1 into the dy dx and x equal to 2 into the dy dx. Alright, so dy dx values depends on x. So if x equal to 1, we will substitute 2 times 1 minus 4 over 1. So we will get 2 minus 4, which is negative 2. Negative 2 will times with the 3, right? So you will get negative 6 units per second. So when x is equal to 2, dy dx will be 2 times 2, 4 minus 4 over 2 square. So 3, right? So 3 is the dy dx when x equal to 2. And we have to times with the 3. So the answer is 9 units per second. Okay, so that is how we find the rate of change of y when x equal to 1 and x equal to 2. So it's actually quite simple. Alright, so let's see self exercise 2.12. For each of the following equations relating x and y, if the rate of change of x is 2 units per second, find the rate of change of y at the given constant. So as you can see, rate of change of x. So what you will write, you have to convert to the 2D symbol. So d means change. So rate means dt. Change of x means dx, right? So it's dx compared with time. Changes of time is dt. So dx dt is equal to 2 units per second. So that is very important. So then after that, you just do dy dx. So dy dx is equal to 6x. 6x. So we'll do. So we will substitute 1 over 2 times 6, right? And times with the dx dt, which is 2. So the answer is 6. Simple, right? So then for the b, we will do the same. So make sure we differentiate correctly. If 4x minus 1 over x squared. So normally we will substitute x equal to 1 into the dy dx. So dy dx is 4 times 1 minus 1 over 1, which is 3, right? So dy dt is actually dy dx, which is 3, times with the dx dt, which is 2. So the answer is just 6, right? 3 times 2. So it's actually 6 units per second, right? Okay, so in short, for rate of change, we need to write 6d, and then we need to form the change rule so that we can substitute. Right, let's see question number 1. For each of the following equation relating x and y, rate of change of x is 2 units per second. So dx dt is 2 units per second. Now find the rate of change of y at the given constant. So now we need to differentiate the y with respect to x. So it's actually negative 3 times 2, 6, and then negative 3 minus 1. So it will be negative 6 over 3x minus 5 to the power of 4 times 3. So before we substitute the x, we always write in simplest form, single fraction. So dy dt is dy dx times dx dt, and we need to substitute the values of x, right? So let's substitute the x into there. So the x is 2. So after we simplify, we will get the answer for the dy dt, which is actually using dy dx times dx dt. So let's see d. First of all, we differentiate will be 5 times 4x minus 3 power 4. And don't forget, you have to differentiate the 4x minus 3, you get 4. So dy dx is 20 times 4x minus 3 to the power of 4, right? So we have to substitute the x equal to half, right? So 20 times 4 times half minus 3. Okay, dy dt is equal to dy dx times dx dt. So we will actually simplify the dy dx by substitute the x equal to half. Okay, after we got the dy dx, we will just times with the dx dt, which was given in the question 2. So you will get the answer finally. Okay, so this is actually rate of change. So the way to do rate of change is actually always convert into symbol. So rate of change of x is 2 units per second, right? So find the rate of change of y at the given instant. So first of all, we need to differentiate the y with respect to x. How to differentiate this one? We have to use the quotient rule. right? X plus 1 times 1 minus x times 1 over x plus 1 square. And then now we are not given the value of x, but instead we are given y. So we need to find the x on our own by using the equation given. So let's substitute y equal to 2 into the equation. So after you substitute, you need to simplify and find the value of x so that you can substitute into the dy dx, right? So after we solve, we have 2x plus 2 equal to x. That means the x value can be found, right? So now we solve the x, and then we can use the x substitute into the dy dx, which is 1 over x plus 1 square. And then we use the formula dy dt equal to dy dx times dx dt, and we will substitute all the value of dy dx and dx dt into the equation, and we can solve the answer, right? So that is how you solve the question involving rate of change using change rule, right? So the x is negative 2, and we substitute into dy dx, we will get answer which is 1, right? And 1 times the 2, so the answer will be 2 units per second. So for f, the same, we will do dy dx is 3x squared. And we also do the same, we need to find the value of x by substitute 10 into the equation. So 10 is equal to x cubed plus 2. That means the x cubed will be equal to 8. So the x is equal to 2, right? Because we cube root the 8. So now we will substitute x equal to 2 into the dy dx. So the dy dx is 3 times 2 squared, which is 12. And then we will actually find the rate of change of y by using dy dx times the dx dt. So it's 12 times 2. So the answer will be 24 units per second, right? So it's quite easy for this rate of change if you follow the way to do. So let's proceed to the next question. For question number 2, same, we have to do dy dx, okay? And rate of change of y was given 6 units per second. So we need to write in terms of the dy over dt, which is 6 units per second. Okay, so after we read the question, rate of change of y. So whenever we see rate is over dt, okay, so we have to write in terms of the symbol so that we can substitute into the equation for the chain rule later. So dy dt equal to 6 units per second. So we are going to find the rate of change of x at the given instant. So how to convert rate of change of x? Rate is over time. So dx dt, we are going to find this. So we will write dx dt equal to dx over something times dx dt equal to dx over something times with the something over dt, right? So now we are going to plug in the dx on top and for the first term, and dt below for the second term. Okay, that is so-called chain rule. Okay, we need to use a chain rule. So of course we will substitute with one more unknown, dy. We always have 3 unknown, right? So dx over dy times dy over dt. So we have the dx dt, right? We have the dx dt equal to dx dy times dy dt. Now we are going to substitute dx dy with 1 over 3x squared minus 4x because dy dx is 3x squared minus 4x, right? So if you inverse, you have to inverse the dy dx, right? We will times with the 6 and then we will substitute the 1 into the dx dy and we will solve the question. Alright, so the answer is negative 6 unit per second. So let's see for B. B, we are having dy dx equal to 2x minus 4x squared, right? Okay, so basically we will write dy there, that's the chain rule, and then let's find the dy dx for B. So dy dx is actually 2x, okay, so let's substitute the 6 first. Now we want to find the dy dx, which is 1 over, okay, 1 over, okay, let's differentiate this. It's actually 2x minus 4x squared, right? Okay, so we're going to substitute the 2 into the dx dy, so we will get the answer which is, okay, so we will get the answer which is, alright, after simplify, answer will be given as shown. So let's go to number 2. Okay, number 2 is still the same. We are doing the we are going to convert rate of change of y as dy dt equal to 6 units per second, and rate of change of the x at the given instant is dx dt. Now let's do dy dx by using quotient rule. So x minus 1 times 4x minus 2x squared times 1 over x minus 1 squared, and then we will write dx dt equal to dx dy times dy dt, and we will substitute all the value inside there, right, to get the answer. When x equal to 3, we will substitute into the dy dx. Alright, so we have to inverse the dy dx to get the dx dy. So we will substitute x equal to 3 into dx dy and times with the answer. So let's proceed to question number 2. It will be the same. So rate of change of y is dy dt equal to 6, and we are asking to find the dx dt. So let's do dy dx. This is actually multiply, so we need to use a product rule. So let's differentiate y, x minus 6 times 1 over 2 square root x minus 1 plus square root x minus 1 times 1. So we will substitute the x value 2 into there. So we don't want to waste time to simplify. So dy dx is negative 1, and then we use a chain rule, dy dt equal to dy dx times dx dt. So that means the dx dt is equal to dy dt times with the dt over, okay, dx. So we'll substitute everything into the equation and we can solve it easily. So most important is your differentiation skills must be good and you must use the chain rule. So for question number 2, we are going to use the quotient rule to do dy dx. Still remember how to use quotient rule. So it's v du dx minus u du dx over v squared, right? So we are going to differentiate y with respect to x. So it's x plus 1 times 2 minus 2x minus 1 times 1 over x plus 1 square. Simplify further, we will get 3 over x plus 1 square, and we need to substitute x value, but we don't have. We were given y. So that means we need to solve the x by substitute y equal to 3 into equation. So finally 3x plus 3 equal to 2x minus 1. that means x is equal to negative 4. So after substitute x equal to negative 4, dy dx will get 3 over negative 4 plus 1 square, right? Then only we can solve the dx dt, right? So after we solve the dy dx, we will use the dy dx for the chain rule. So dx dt is equal to actually dy dt dy by dy dx. So then we solve the equation using chain rule, we can get the answer for the dx dt, right? So that is so-called solving rate of change. So let's proceed to question number 2. We are given y equal to square root 2x plus 7. Okay, so let's differentiate the y with respect to x. Okay, so the dy dt value still given 6 and we are asking to find dx dt. So dy dx is 1 over 2 square root 2x plus 7 times 2. Don't forget times 2. So we are going to substitute the x value, but we don't have the x value. After we simplify, the dy dx is just 1 over square root 2x plus 7. The 2 can be cancelled out. So now we want to find the value of x. We need to squaring both sides, alright? Become 9 equal to 2x plus 7. So 9 minus 7 is 2. That means x is equal to 1. Substitute x equal to 1 into the dy dx. We get 1 over 9, which is 1 over 3. Now we are going to write dx dt equal to dx dy times dy dt, and then we have to inverse 1 over 3 times 6. We become 6 times 3. So the answer is actually equal to 18, right? Okay, the answer is 18. Okay, so let's proceed to the next question. For question number 3, a curve has an equation y equal to x minus 8 square root x plus 4. Find an expression for dy dx, and then the rate of change of y when x equal to 5 if x increases at a rate of 6 units per second. So first of all, let's dy dx using the product rule. So that is how you differentiate. So the dy dx is actually a bit complicated. So we need to substitute the x value into there, which is given the x value is actually 5, right? So we will substitute the 5 into the dy dx so that we can use the dy dx for the part B. So our dy dx is actually simplest form in single fraction. So now we are going to write dy dt equal to dy dx times dx dt, and the dx dt was given 6 units per second. So then we will substitute x equal to 5 into the dy dx, 3 times 5, and then we simplify. We will get the answer for the rate of change, okay, of y, rate of change of y, which is dy dt. Okay, so always double check so that we won't have careless mistake. Right, so it's actually substitute x equal to 5 into dy dx, and we just times with the 6. The answer is 1515 units per second. So have a beautiful day. I really hope that my sharing do help you to have a better understanding of how to solve the rate of change using chain rule. Okay, till then, I shall see you in my next video sharing. Bye bye and have a beautiful day.